Next, we will look at Excel functions that are designed to operate on two columns of data or two rows of data at the same time. In other words, they're designed to operate on ordered pairs. Okay? So let's assume that our x-axis values are the returns of the S&P 500 index, and our y-axis values are our returns of Duke Energy stock for the same month. So we're creating ordered pairs. Each ordered pair represents 1 month of time, 2 different returns. And I'd like to know what the best fit line that fits that data looks like. Okay? If they were perfectly correlated, you'd have quite a steep line. If they had no correlation at all, you'd have a very flat line. We are going to see what the slope of that line is. And the way that we do that is we do the Excel slope function. Notice that it asks you to enter the known y's first. So here we have to enter E4 to E178 first. Just as we did before, we indicate the top and bottom of the array and all the cells in between with a colon. Now we separate with a comma, and now we're going to put in the second array. Okay, and this value we don't want as a percentage, we just want it as a number. So I'm going to go back to restore the number for that. Okay. Now I'd like to know, on average, did Duke Energy stock outperform the S&P 500 index? And one way of calculating that is to calculate the y-intercept, or what would be the expected return of Duke Energy when the S&P 500 index had a return of 0% or was flat. And the Excel command for that function is intercept. And again, I'm going to do my known y's first. So I'm going to do E4 to E178, comma, D4 to D178. And my intercept, as you can see, is slightly positive. And here I think I would like a percentage value. So over this period of 14 years, on average, Duke Energy stock would return about 0.5% if the stock market itself was returning nothing. Okay. Now, we've seen that these values move differently, but a common question is, how differently do they move? Are they always up together? Are they always down together? And Duke Energy just moves up more and down more, or do they have some independent movement? For this, we're going to calculate the correlation. Okay. And here it doesn't matter what order we enter them in, because the correlation of x against y and y against x is the same, but we'll just do it the same we've been doing it. And we see that the correlation is significant, but not overwhelming. There's a lot of independent movement here. So what this tells us is that Duke Energy stock often goes its own way. It's often down when the overall stock market is up, and up when the overall stock market is down. For a well-performing stock, this is a desirable characteristic because it allows us to create greater diversification by having assets that are not all highly correlated with the stock market index as a whole. R squared can be calculated two ways. it has its own function in Excel, or we could simply take the square of the correlation, but I will just show you the R squared function, RSQ, which is, again, I generally recommend, just as a matter of keeping spreadsheets clear and orderly, that you limit numbers to a reasonable number of digits, because after about 2 digits they are not significant in any case. So I just formatted and reduced this to 2 digits to the right of the decimal sign, and there you have our answers. There's another way to calculate statistics about our best fit line that relates Duke Energy returns against S&P 500 returns. And the way that we would do that is we would select both columns of data. Okay. Then we go to Charts, Scatter. We're going to choose the marked scatter. And this is a picture where each dot represents 1 month's activity, and the x-axis represents the returns of the S&P 500, and the y-axis represents the returns of Duke Energy stock. This picture doesn't give us the descriptive statistics, but it gives us a general picture, which suggests that there's some association here, though not a high amount of association. So I can add the descriptive statistics I want by going to Charts, Chart Layouts, Trend Line, and now I am going to add a linear trend line. Okay. And again, I'm going to go to Trend Line Options, and I am going to go to Options, and I am going to say, yes, display the equation on the chart, and yes, display the R squared value on the chart. And now, that may be a little bit small, but if you can see that, you'll see that we have a formula for y in terms of x of 0.4863x plus 0.0051. What that means is the slope of the line is 0.486, which is exactly what we found before, and the y-intercept is 0.0051, which is exactly what we found before, and the R squared value is 0.11, which is exactly what we found before. And that concludes our demonstration of how you can use Excel on arrays of data.